Okay, so good evening, everyone, and we'll start the stereochemistry, advanced stereochemistry part 2. Here I will mainly discuss the topicity relationships and some more fundamental topics. So in previous classes, I discussed with how to we put the nomenclature on the compounds having different kind of chirality like axial chiralities and plane chiralities, helical chiralities, these kind of things. Here, so I will start from the very basic things because we might forget some more fundamental part, or we might have some confusion about the more fundamental part. So for that, we'll start from the very basic, and slowly we'll take you to the advanced examples. And at the end of the class, you will find that so when you have been given a compound that looks very much complicated, and how just after looking the compounds at a glance, how you can find the topicity relationships less than 30 seconds. I'll show at the end of the class you will achieve that part. Okay, so let's start with the very basic thing I told that we might forget. That's why these discussions it about stereogenic center. We all know about chiral centers that we can easily say, okay, so if I have 4 different atoms with carbons or 4 different groups in carbons, these are called chiral. We sometimes might confuse with the chiral center and stereogenic centers. So that part I will clear here. So what is the simple definition of stereogenic centers? So in a molecules, if we have such center that if two of the group attached to that center are interchanged to different isomer form. So that sentence looks complicated, but it's very easier to understand and very much easy statement. So if two groups, for examples, if two groups or let's say it's two groups. So attached to a, for example, particular centers. It attached to a center. Now, if two groups are interchanged, it's a BSc part. If two groups are interchanged, we will get two different isomer. So that's the concept of stereogenic center. That's the different of stereogenic center. Let us think. It's very easier things. Let's say it is Cl here, it is H here, it is H here, it is Cl here. So we try to find if this is asked, is this stereogenic? Then we'll follow our standard protocol. We'll interchange two groups. For example, now it is H here, Cl is here. If we interchanged H and Cl interchange, then what we'll find or what we will have, this is Cl, it was here, H is here, this Cl is go there and H. Now look, it's a trans isomer and it's a cis isomer. So we now get two different isomer upon interchanging. That's why this center is a stereogenic center. So stereogenic center is much more prominent than the sometimes the word chiralities because it's a stereochemistry. That's why the name stereogenic is much more prominent. And same thing, so if this center is also stereogenic because upon interchange these two groups, Cl hydrogen, these will produce two different isomers, cis and trans. So that's why now just using the simple traits, that's interchange two group, we are getting two different isomer, not we find stereogenic center. Later, Our next slide, I'm moving quite post-stereogenic center. This is a quite earlier concept of stereogenic center. We will have definitely its pro means it is not stereogenic now. For example, this is H, this is Cl, H, H. For example, question has been asked, you just mark these two carbon, which is stereogenic and which is post-stereogenic. Post-stereogenic means we'll have the same group. So these two, sorry for convenience. So these two groups are same. If three groups are same, I will just change one group by another atom. So change one hydrogen by, let's say, Z. So what we are getting now? We are getting H. This is Cl, C, H, and Z. Okay. Now we'll check. Now we have some new center, right? This is a new center. This new center, upon interchange, it can produce two different isomer or not. So let us interchange H and Z. So we are going to get C double bond C. One H was here. Now it will be Z and H. H and Cl. Look, it is a trans case. And here it was the cis case. It was the cis isomer, trans isomer. So we'll find that upon replacement one of the hydrogen by another group, or upon replacing one hydrogen by another group, and upon interchange that hydrogen and Z, we are getting two isomer. That's why if you want to configure this is a post-stereogenic center. Post-stereogenic center means just before the stereogenic center, anything happen to the group, it will be stereogenic. That kind of concept. And this is stereogenic center. Now here, what I am showing, just you have to calculate. You have to just do. You have to do some exercise. Just replace Z and H, these kind of things. I promise you, at the end of my class, I'll reach you to a such situation. Whatever the complicated molecules, you will look at the molecule and you will able to say what is the things it being asked and how quickly you answer it. Okay, so this is sorry, so this is not stereogenic. This is not stereogenic because if you interchange these two, this is definitely going to produce same molecules. Let's say it's a molecules having three substitute on Z. Now interchange. Let's interchange H and Cl. So upon interchanging H and Cl, what we are getting? We are getting, it was H as usual. Now it will be Cl, H. Same molecules. Same molecules. So if this question is asked that what is the configuration of the center, so one is non-stereogenic, another is post-stereogenic. So if we have one substitution at ethylene, only one substitution, let's Z, then this center is non-stereogenic and this center is post-stereogenic. This will be very much helpful for the exam purposes, competitive exam purposes like CSIR, NET, GATE or IIT exams, if that much fundamental question is being asked. Now I am asking a very fundamental question second. Can a molecule will be achiral in spite of having stereogenic centers? Very much fundamental question. Okay. Before that, let's say, what do we mean by chirality? When we say the word chirality, it comes in our mind that if we have four different groups attached to a carbon, provided A does not equal to B, does not equal to C, does not equal to D, it appears as chiral. Okay. Now I am drawing the molecule, let's say with stereochemical descriptions, means just I am putting this kind of things to indicate that some groups is above the plane, some group is below the plane. So I can find that C is below the plane, sorry, above the plane, and D is below the plane. Now we interchange C and D. Just interchange C and D. So we are going to get, as it is A, it is V. Now this is going to D and this is going to C. Look, as these groups are different, now these two are enantiomer, basically two different isomer. Enantiomer. I will not say enantiomer right now, just let's say two different isomer. So just two different isomer. Definitely it's enantiomer, but I am focusing on the two different isomer. So these are also stereogenic center. Stereogenic center. Interesting point is that we normally call this carbon as chiral. Rather now I call it this as a stereogenic center. Okay. So next one is that. Okay. So before that, let us discuss something before putting focus on that. So all chiral centered, as this is chiral, so this is the definition, this is chiral. Not only chiral, we find that this is also stereogenic. Stereogenic. This is chiral as well as stereogenic, because if we interchange any two group, this will produce two different isomers. Look at there. Think about this molecule, HCl and HCl. If we interchange any two group, this will produce cis trans isomerism. That's why it is stereogenic. Stereogenic. So what we find? We find that this molecule is stereogenic, this carbon center is stereogenic, but it is achiral. Achiral. So the general statement is that all the chiral center are stereogenic, but not all the stereogenic center are chiral, because this is no chiral, is achiral. So let us write down the statement. Very interesting statement. The crystal clear concept. All the stereogenic center, all the chiral center are stereogenic. All the chiral center are stereogenic. Stereogenic, but not all stereogenic center are chiral. Stereogenic center are not chiral. Sorry, are not chiral. Okay. So if we have the questions like fundamental understanding, sometimes we might confuse. This is a very much confusing part of the students as well as the teachers also. But just you remember the example, just hear these statements, you will never get in confusion. So all the chiral center are stereogenic in nature, but not all the stereogenic center is not chiral. Now let us answer this point. Can a molecule be achiral in spite of having stereogenic center? This answer you all know. It's for meso compounds. Let's say, so this is mesotartaric acid, C OH OH C OH OH and COOH. So this center is, for example, stereogenic. This center is stereogenic. Basically, this is answer already I have done. Achiral means, so this is, you find that this is achiral and stereogenic. But here I am showing some different things, that a compounds can have stereogenic center, but still the compound is optically inactive. That part I am going to. Okay. So basically, you find that this compound has a plane of symmetry, and due to this plane of symmetry, this compound is optically inactive. Optically inactive. So what I am discussing there, two things. If I summarize, that a molecule can be achiral in spite of having stereogenic center. These molecules have stereogenic center, but it is achiral. And another thing I have generalized, that all the chiral centers are stereogenic, but not all the stereogenic center are chiral. Here I have another interesting things. that a molecules having in spite of stereogenic centers, it may be optically inactive, or a molecule in spite of having chiral centers, it may be optically inactive because the meso compounds, it has two stereogenic center or two chiral centers, but due to plane of symmetry, it is optically inactive. So this part will help us not only to learn but also to understand the very basics, fundamental questions. Okay, now I am going to the part where is routinely asked the questions. If you face the competitive exam like CSIR NET, GATE, IIT exam, maybe BRC or assistant professor for PSC, these questions you'll face routinely. So the question is, what is the topicity relationship between this HA and HB? How to do that? So the rule is that just we have to replace, let's say we replace this HA by Z, another group. So just replace by Z. Here in this class, I will show you varieties of questions, varieties of examples that can be asked, that can be easily handled. You will understand. Now, in this case, I'll replace these problems you might know, not might, definitely you know, just for understanding or just for revision, recapitulation, I am doing it. So let's replace is B by Z, another group. CWH, in this case, we have, sorry, this is Z, OH, C, this is H, this is OH, this is CWH. Now we have those two things. Let's say this is the 1 and this is 2. Now you have to find the relationship between 1 and 2. So our task is, our job is, find the stereochemical relationship between A and 2. Relationship between 1 and 2. And this is H, this is OH, this is CWH, CWH, H, OH, Z, HO, CWH. Now things, just simply I am telling what you will do. There are many things that can be told here. Just point the C2 axis, then rotate 120. Just I am telling nothing. Just rotate the molecules just in this fashion by 180 degree. If you rotate the molecules in this fashion 180 degree, what I am going to get? This CWH will come upsides. Look, this CWH come upside. Just I have pointed out this circle, and this will come downside as a result. So C. Now I have make it just to make understand. This Z will come here. Look, this is the Z here. This OH will go there. This is the OH. I marked it. I have make it triangle. This triangle OH will come here. And let's say I make this hydrogen square. So this square will come this sides. Look, upon that, these two molecules are same. These two molecules, COH, OH, Z, OH, H, COH. So if you rotate a molecules and get the same spatial distribution of the molecules with another molecules, it means that two molecules are same. Basically, these two molecules are homomer. So stereochemical relationship between HA and HB, HA, HB are homotopic. It needs exercise, but it is a good practice for us. But believe me, when I will finish all my 4 classes on stereochemistry, just I am very much confident you will find any question for any exam on stereochemistry and let me know. Okay, sir, after your discussion, I am finding some difficulty to solve this problem. It won't happen. I can keep guarantee on that. That the diversity that will maintain during my 4 classes, those 2 is very big chapters, but I will try to maintain all the things, try to cover all the things. Now, look at the topicity of these molecules. I find that that is the homotopic. Your job is now routine job. You have to replace one HA by Z. To do that, HA replaced by Z. And Cl as usual, it was, I'm just drawing that ClH. Now replace HB by Z. Replace HB by Z. So we are going to get these things. Z, sorry, it is H now, and this is Cl, this is Cl, this is Z, H, H. So we have 2 molecules. Now these 2 molecules are ready. We have to find their stereochemical relations. So one basic concept, easy concept, just rotate the molecules and find this is matching with the another molecules or not. You can do this job for any of the molecules here. And that's just, you know, you don't need to do anything, just make upside down for these molecules. For example, so let's say this is the axis. Around this axis, just upside down. Upside down. Or basically I'm telling that 180-degree rotation around this is C2 axis. Just I'm trying to avoid this terminology. That's why I told that to upside down. If you do that, that Z is coming here. This cell is coming here. And this cell is coming here. And this H is just coming here. And this is as usual. So find these 2 molecules again, same molecules. Same molecules means homotopic. Homotopic. So again, we find the stochastic relationship between these 2 homotopics. So we do exercise for 2 molecules, how to calculate that homotopic groups or homotopic relationship in a ligand. Now, I'll show you. Let us do the same exercise for these molecules. Then, okay, we just replace it by Z, so it is between this H. If you don't like Z, then if you can do with any group you want, just do that. Let's say I wish to do it by bromo. So it is Cl, H, 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 and here I want to do it again by bromo. So this is Cl, this is Br, this is Cl, and this is H. As usual, H and H. So now for this molecule, if you do upside down, then it will not match. Do this exercise, it will not match. If don't match, then what we will do, our next job, find mirror image relationships. Our first job will try by rotation around C2 axis. If we do not found, our job is to get mirror image. Basically, it will be our third job, not second job. Why I'm telling this will be a third job, after a couple of slides you will understand. So this is a mirror image, find mirror image. So just take these molecules and take this mirror image. This is Cl, H, this is Cl, we just put the mirror here. Then what we will find? We'll find, see, this is the triangle on the other side of the mirror. We have this Cl, Means this cells is here, this is going to come here, and we'll have these things Cl and Br as H. Now look, these two molecules, let's say if it is 2 and if this is 1, look, these two molecules are same. So basically 1 and 2 is mirror image. Which kind of mirror is? It's a non-superimposable. Non-superimposable. That's why it's an enantiomer. It's an enantiomer. So the topicity relationship between these two hydrogen is enantiotopic in nature. Enantiotopic in nature. And this is the part where the students avoid the question very much. But believe me, this is the part, this is the most scoring part. So just do not be afraid about this part. Just face this problem, have some practice, have some tricks, have some real visualization to the molecules. You'll secure all the full marks, whatever the problem is given. So now look. So just have a look on these things. Just a slight change. And after this slight change, the problem becomes much more easier. Let us replace one hydrogen by bromo. It is as usual hydrogens H and H. Slowly, now we are in a frame. We'll just avoid this kind of practice. Now we'll start using the tricks. One thing we can easily do it by tricks. I'm just going to show soon. Okay. Now take these molecules. This is 1 and this is 2. Okay. So this is Br, this is H, this is H. If we put a mirror here, then what we are getting, this is now H, this is Br, this is H and H. Again we find non-superimposable mirror image. Okay, so it is, so these two are enantiomer. So it is, these two hydrogen are enantiotopic. Enantiotopic in nature. These two are enantiomer. Okay, sorry, this will be Cl, this will be Cl. Yeah, okay. Now, if it is given some different kind of examples, for examples, this one. So this one normally people gets confused, but we will not do that. It is very simple. If you look at the molecule, just have visualizations, you can easily do that. For examples, just do this routine work. Don't feel bored, because as I am practicing the same thing again and again, you might feel bored, but do not do that. I will move from this technique to another technique. Let's just do that C to Z, and it is CH3. Why I'm doing the same thing again and again, so that you do not miss the marks in exams from this part. That's why I'm doing the same thing again and again. Whatever I am practicing, your practice would be more than 10 to 15 times than me. That's why I'm doing the putting the same thing again and again. This is Z, and this is again CH3. It's a VSC part 1 problem. What is the relationship between 1 and 2 prime? We can easily see it's a non-superimposable mirror image. Just put the mirror, let's say on the screen. If you put the mirror on the screen, let's say this screen is the mirror. Let us visualize, this is the mirror. Then it was on the front part of the mirror. So the image side is just going to the back side. And it was in the back sides. and now it is coming on the front side. So what we are getting, 1 and 2 are non-superimposable. Try to superimpose it, it will not. It is non-superimposable mirror image. Mirror image. Okay, so that's why it is enantiomeric. These are sorry, enantiotopic. Enantiotopic. So right now what I did, I take example from some books and solve the problem. With this knowledge, we'll move to the real problem that is normally asked in the exam, like CSIR NET generate exam. You'll find that how quickly, how easily you can solve that. So this is enantiotopic in nature. In nature. Okay. Now these things. That's we use the tricks. Okay. Now do this interesting routine work. What is a routine work? You replace it by BR. H. So replace by BR. Now you replace HA by BR. Replace by bromo. So what we have now, it is bromine here, it is hydrogen, HCl. Look at the molecules. Here we have C double bond C, HCl, Br H, and look at here, HCl, Br H. It is cis and this is trans. We have two different molecules. Cis trans are nothing, they're diastereomeric in nature. So these two hydrogen are diastereotopic. Diastereotopic. Cis trans are because they have different bond connectivity. Cis trans has different bond connectivity. Different bond connectivity means they are diastereomer connectivity. Hence, they are diastereomer. Diastereomer means these two hydrogen are diastereotopic in nature. And diastereotopicity, the interesting thing about diastereotopicity, the molecule looks the most complicated among the homotopic, enantiotopic, diastereotopic, but this problem can be solved in a second. Now I will show you the tricks, how I am telling these things. Diastereotopic can be solved in a second. Let us these things. It has been asked what is the topicity relationship between this hydrogen and this hydrogen. This molecule looks complicated, you might fear. Now I am doing the first routine work, then I will go to the tricks. Let's say this is the problem that need the least time to address that. Let us think I have replaced it by Z, and this is the hydrogen as it was. And here this HO, this is H, CH2, OH. Here I need your visualization the molecules. And here I am replacing another hydrogen by Z. H, C double bond O. Here, let's say this is Z, and this is the H, and here we have OH, sorry, H and CH2H. Look, first of all, you just try by rotations, it will not the same molecules. You try to find mirror image, it will not act, because if you want to find mirror image, and after taking as let's say, I am not telling, let's say it is S. It may be R, maybe S, we don't know, we didn't check that. Let's say S. If S, after taking mirror image, if you take the mirror image, it's not this one, but if you take the mirror image, then it is going to be different. It is going to be R. I am telling that. So after that, their configuration is going to change. One is R and is going to S. That is two different isomers, right? For example, you put the image here, sorry, mirror here. For example, the plane of this screen is the mirror. Then what we found, the Z's was in the upsides that go to the downsides. Look, that is the fundamental point. Just for understanding, I am telling downside. It was on the back sides. Let's say it is go to the front. It come to the front. So here it's changed. Mirror image relationship is here. Okay. If you want to do the same thing, then you realize that here the configuration will change. Okay. If this become R, then that is going to be S. So that is supposed that to different molecule. So it's takes some quite complication. But now here I'm putting the ticks. So you'll find that these two molecules to diastereomer. These are the diastereomer. Okay. So mirror image is not possible here also. If the mirror image possible, if it was S, then after that it's supposed to be R. Supposed to be R. Supposed to R. If proper mirror image was there, but not. It is the same thing. Whatever it is there, it is also there. So it is not R. Again, this is S, basically. I think I'm making quite complicated, but you have to understand. These center interchange, but these do not interchange. It indicates that if it is S, is supposed to be R if it was interchanged, but it is again S, so it is not interchanged. It means that these two groups are two different groups. So this is 1 and 2 are a diastereomer. Just listen my statement. You just close your eye and try to understand. This is a not complete mirror image relationships. Only this group has mirror image relationship, but not this big group. That's why these are two different molecule. If this is two different molecule, then these are diastereomer. Mainly question is asked from the diastereomic part. They are diastereomer, so these two hydrogen is diastereotopic. But students, stereotopic. You no need to solve the problem in this complicated fashion. This is not at all complicated fashion. This is the real the scenario that should people follow. But the tricks is but you follow this thing. If you find any chiral center in a molecule, we have noticed this is a chiral center blindly. That two hydrogen is going to be diastereomer. So now it is taking the more than 30 seconds. We notice, see, after this kind of a large homework, we are discovering or we are just proving that these two are diastereomer. That is, these two hydrogen are diastereotopic. But for our understanding part, we did that. We don't need this part for our question solving part. We have find one chiral center in the molecules. That's why these two hydrogen, just in a second, you just close your uh, answer script but in the diastereomeric part. So these two are diastereotopic. Diastereotopic. So that is the tricks. Find if found any chiral center that is given topicity relationship will be diastereotopic. Given topicity relationship will be diastereotopic. I hope you have enjoyed this part. Because these tricks will solve the real problem in the exam givens. Okay. So another thing, why I have given this here. For example, topicity means normally we think about hydrogen. So if it is not hydrogen, it is methyl. Then if it is find the topicity relationship between this methyl group, then what we will do? Our same job. We'll replace one methyl group by another group Z, and this is methyl. These are phenyl. This is a problem from the competitive exams. Here I have to do the exercise, but you don't need to do the exercise for your exam purposes. Just if you can visualize the molecules, easily you can do that. Z. This is phenyl. That is phenyl. So now we have two molecules is ready. We'll see what things we find from here. This is Z. This is methyl, phenyl, and phenyl. Z, methyl, phenyl, phenyl. So just have a rotation by 180 degree. You find what is going to be. This Z was on front side, the borderline, it is coming on back sides. This methyl, let's put a triangle, was back sides, it is coming on front side. This phenyl, sorry, it will be bold one. This phenyl was on back side, so it's coming on front side. That was on front side, this coming back side. That is, we find these are the same molecule. Same molecule. So these are homo. So these two methyl group will be homotopic in nature. Very simple thing to answer. So these two methyl groups are homotopic in nature. Two methyl group are homotopic. So topicity means you never think that it only hydrogen will be given. Some groups also can be given, but do the same treatment for that. It's a CSIR net questions. Yes. Now I take to the real scenario. These two questions are the questions from, I think it's from date or CSIR net. Due to technical purpose, I didn't put in which years. Okay. So this has been given. Now I told the opposite relationship. If it is given, the people or student will might find with seeing the molecules. Look, previous classes, I told here we have a chiral axis. That is, we have pointed out a chirality. Maybe it is chiral center or chiral axis. We have pointed out a chirality or chirality is observed in the molecule. Is observed in the molecule. I told if chirality is observed, then these two hydrogen is going to be diastereotopic. Without any exercise, we are doing that. Diastereotopic. As we have noticed on chiral centers. That is, we can have mirror image relationship here by interchanging, but these but same. So that is, we will have two different diastereomer. That was this was diastereotopic nature. Look at here also, HB and HA. You no need to just replacement now for this case. If the problem is given, just first check it is diastereotopic or not, because just try to find whether I can find the chiral center or not. I no need to replacement big or large just practice. Look, this center is chiral center. Why chiral center? Four different group attached. One bromo, one methyl, another this group with two hydrogen, another bromine. So this is a chiral center. If this is chiral center, now we have pointed out, we have spotted out one chiral center in the molecules. One or more than one, whatever. We have spotted out some chiral center. So chiral center spotted. Spotted. That's thing. These two HA and HB are diastereotopic. Okay, so we can easily do these things that the chiral center is found, this will be diastereotopic. If there is no chiral center, this will be either homotopic or enantiotopic. Just homotopic, just rotate the molecules. If you don't find it is not matching, it will be enantiotopic. In that way, using these kind of tricks, we can easily find out whether it is homotopic, enantiotopic, or diastereotopic. Again, I am repeating, just find chiral center. If it is find chiral, it is going to be diastereotopic. If no chiral, we have two options, either homotopic or enantiotopic. If it is do not rotate, sorry, it is do not match after rotation, this is going to be enantiotopic. You can easily do that. So, okay, now I'm going to some different kind of problem. Basically, it can be asked for. It is a very good question for uh, competitive exams. So look, so what is the relationship between the compounds? It's enantiomer, diastereomer, homomer, or constitutional isomer. Because I am telling the questions two days now, because in the first day we did about the allene R and S. Except R and S, what type of questions can be asked from allene? It is nothing. Just you think, just to close your eye and try to visualize the molecules. It is on the front side. It is back side. Just these two are on plane. Now you rotate the molecule 180 degree. Rotate means you just around this axis, you rotate it, or you can rotate on this plane also. You can rotate around these things also. If you rotate this, then this circular hydrogen marks, not circular, hydrogen marked by circle is come here. This pro marked by circle again will come here. No problem with that. Or then, okay, just do it in more perfect way, not perfect, more easier way. You can rotate around this axis. Then this here was front, that is going to back. This was on back, is coming front. What will happen? This will go back. Look, this which was on front, now it is on back. That is, on rotation, we are finding two molecules. So these two molecules are same. Two molecules are same. That is, this is homotopic. Not homotopic, this is a homomer. This is homomer. So from allene, we can have two type of questions. One is just RS nomenclature, another is that just this kind of things. So believe me, if you have a look at the question, this kind of question are only tough question from the stoichiometry part. Other question I didn't put into account that it's a simple basic question. Just look at the molecule, you can do that. So this is the question normal student gets confused. That's why I discuss here. So what I did, I summarized in my first classes, I have emphasized different chiral centers and their nomenclature. In the second classes, I emphasize on stereogenic centers and some relationship, all stereogenic is chiral or not, these kind of things and blah blah. And then I have done the emphasis on the topicity. That is a remarkable part from the question can be asked. In third classes, I will look different conformation analysis of cyclohexane, like decalin system, their Newman projections, and so many things in the third and fourth classes. After this fourth classes, you find any question for competitive exam and let me know, sir, okay, you taught us and we are unable to do the question. It will not be. Okay, so you will have a clear-cut idea about this these discussions. And also I request the students, if you have any understanding, just let me know through WhatsApp. I have got a lot of points from a lot of students regarding previous classes. I am happy to answer them all. And also I expect some input also. And the class will be available on recorded version in YouTube And I hope you have enjoyed the class. And thank you for being present and listening. Student, today I will end here. I will stop the class right now. And next class, I will go on the conformation analysis of cyclohexanes or some different cyclohexane analogous compounds. Okay.